All right, guys. I am going to start sharing my whiteboard so that way we can go over some of the concepts. I know that today, specifically, we had a little bit of technical issues on my side. My internet crashed, and I know that after that, some of you were unable to rejoin the meeting. So I'm going to record this class, and hopefully, this will be helpful for you guys. For you guys to be able to work with. All right, so today we're going to be talking about measurements, and um we pretty much established what measurements were, and we established that there exists a system of measurements that is used to worldwide in chemistry and other sciences to kind of make sure that all of our data is the same. Excuse me for a minute here. So the section for today is entitled Units of Measurements. And I'm going to go ahead and read some of the highlights or the notes that were taken in class today. And we're going to go over some key terms such as quantity, SI, weight, derived unit, volume, density. Anyway, so here we go. It says measurements are quantitative information. So the first thing that we need to understand is that a measurement is a quantitative information. And of course, by quantitative, you understand numbers, although it's a little bit more profound than that. But basically, measurement is quantitative information. Okay, our measurements are quantitative information. Measurements are quantitative. Excuse me for my horrible grammar. Quantitative information. Okay, so a measurement is pretty much a number, right? Although it does go a little bit more profound than that. Okay, it says a measurement is more than just a number in everyday life. Suppose a chef, and it gives us an example. Measurements are just more than everyday numbers. So a measurement is more than 3, 2, or 5 or 6. A measurement has to represent a quantity or has to represent a value. And it goes on to say that, for example, if a chef needs to create a recipe and he says, well, 1 salt, 3 sugar, 2 butter, but you don't know what that means. You don't know if it's 1 teaspoon, 1 tablespoon, 1 ounce, 1 gram. So that's what that analogy is saying that measurements are more than just a number. They represent something, okay? And it goes on to say that measurements represent quantities. Okay, so a measurement represents a quantity. That measurement represents a quantity. That the teaspoon represents how much in the case of the chef, which would be 3. If we were using teaspoons, it would be 3 teaspoons. Okay, and it goes on to define quantity as something that has magnitude, size, or amount. Okay, quantity can be defined as something that has, or I'm sorry, not something. I apologize for that. Well, actually, that's the exact definition of the book. Yeah, I thought I was wrong. A quantity can be defined as something, excuse me for this misspelling here, that has magnitude, size, or amount. Okay, that has magnitude, size, or amount. Okay, so 3 teaspoons or tablespoon is a quantity because it has a measurement. Or excuse me, is considered to be a quantity. Yes, it's considered to be a quantity because it has a magnitude. It has a size. Okay, it doesn't have to have all 3. It could have one. It can have 3 of them, or it can have 1 of them, or 2 of them. In the case of tablespoons, it's giving us an amount, 3 tablespoons. You need to use 3 tablespoons or 3 teaspoons of salt. Okay. So the section, or the beginning of this section, goes on to saying that a quantity is not the same as a measurement. For example, the quantity represented by a teaspoon is volume. So quantity is not the same as a measurement, and that's a good difference or contrast to establish, because that's a big confusion. Quantity is not the same as a measurement. Okay? Quantity is not the same thing as a measurement. So for example, and it says, for example, the quantity represented by a teaspoon is volume. Okay, so a quantity represented by a teaspoon is a measure of volume, or is volume. And of course, we know that volume is how much space an object takes up. So basically, when a quantity is not the same thing as a measurement, and a quantity represented by a teaspoon, for example, is volume. Okay, so it's very common to have people confuse one or the other. It says the teaspoon is a unit of measurement, while volume is a quantity. So a teaspoon is a unit of measurement and volume is a quantity. So that's also important to understand. Teaspoon is a value of measurement, while teaspoon is a value of measurement, while volume is a quantity. Volume is a quantity. Okay. And it goes on to say a teaspoon is a measurement standard in this country. Units of measurements compare what is to be measured with a previously defined size. Nearly every measurement is a number plus a unit. So that's always good to understand, that nearly every measurement is a number plus a unit. 3 inches, 4 tablespoons, 5 feet, 7 meters. There's a number and a unit. So measurement is almost always represented with a number and a unit. Okay. Measurement is almost always is almost always is almost always sorry about that. I've been having internet problems today. Is almost always a number plus a unit. For example, 777 meters. Okay, so that's another good piece of information. And then we're going to talk about the SI system. Okay, and it says that scientists all over the world have agreed on a single measurement system called Le Système International des Units, abbreviated SI. So the SI was basically, or is basically, a system in which scientists all over the world use to represent measurements. So the SI system is used by scientists all over the world. Used science all over the world to represent um, units. So before this, and I'm actually going to clear this all right now. Before this, there was no system, and a foot, for example, was kind of like a derived unit or a common unit that that was used a lot around the world, and it's called a foot because it was literally measuring the distance by using the measurement of a person's foot. But the problem was that in that case, everyone's foot measurements was different, and for years there were different measurements. In fact, some people suggest that probably the fact that the SI wasn't established until 1960, that before that people who were working in the space race in the early 60s and in the 50s and the 60s, that a lot of those experiments could have failed because the units were not the same. For example, in the United States, we don't use kilograms to measure a person's mass. We use pounds, and in European countries and other countries, they used kilograms. So maybe that confusion could have caused certain missions to go astray. In that same section, it goes to say that the SI now has 7 units, and most other units are derived from these 7. So the SI has 7 base units, and the derived units come from the first 7 units. So there are 7 base units, and the other units that we may see that are used to measure other quantities are derived from that. For example, meter is used to determine distance, and seconds is used to determine time. And if you combine meters per second, you get velocity, which is distance over time. So that's an example of that. Although we're going to see that a little bit later on in the chapter. It says that the SI units are defined in terms of standard measurements. The standards are objects or natural phenomena that are of constant value, easy to preserve and reproduce, and practical in size. So basically, the SI units just make it easier. So just trying to say it makes it easier and it's more practical to determine the measurements that they're using. It says, for example, numbers are written in form that is agreed upon internationally. So even numbers are written in a form that are agreed upon internationally. And in class, I was explaining 75,000, for example. And this is, of course, all on page 31 of your textbooks. And then we're going to go on to page 32. And page 32 talks about the prefixes. Okay. So in the SI unit, it says that we have prefixes added to the names of the SI base units. So it says that the 7 SI units and their standard abbreviated symbols are listed. So if you go to figure 2.1, you'll see all the SI units that are listed. 2.1 in your textbook. It says all the other SI units can be derived from these 7. Prefixes added to the names of SI base units are used to represent quantities that are larger or smaller than the base unit. So the base unit is going to have a quantity, and that quantity is going to represent if the unit or it's so that prefix, excuse me, is going to represent or tell us if the quantity is larger or smaller. Okay, so let me write that down. Um, the prefixes in the SI unit are um, used to determine the size to determine the size of the base unit. For example, I know that kilogram is used for mass. We're going to see that in a minute. And kilograms is for larger objects. But if instead of adding, and let me explain this right here visually. What that means is, for example, as I said, kilogram is used to determine the mass of generally large objects. Okay. If I said centigram instead of kilograms, and centigrams is represented with the letter C, this means that, or this prefix tells us that this represents the mass of a smaller object. Okay, so that's one way. That's pretty much what it's saying. Okay, we're going to talk about mass in just a minute, but it's just to establish the difference. And we're going to talk about mass real quick. It says, as you learn in the chapter Matter and Change, mass is a measurement of the quantity of matter. The SI standard unit for mass is the kilogram. The standard for mass is defined in figure 2.1, is used to calibrate balances all over the world. A kilogram is about 2.2 pounds. So very important that we know that a kilogram equals 2.2 pounds, or is about, because it's an approximated value. 2.2 pounds, especially when we start working with mass or with unit analysis or dimensional analysis. So basically what this is saying is that the kilogram is the unit that is used to measure mass, and that a kilogram is about 2.2 pounds. If you go on to the next page, and it goes on to say that the gram G, which is 1/1000 of a kilogram, is more useful, or is a more useful measurement for measuring the masses of smaller objects such as flasks and beakers. So let me clear this so that I can write down what I just mentioned. So basically, grams, which is represented with the letter G, is used to measure the mass of smaller objects such as flasks and beakers. So like I was mentioning, kilograms is used for large objects. In fact, in most countries around the world, weight of a person is not determined by pounds like we have here, but it's actually determined by the mass of the by the kilograms. Excuse me. So if your weight here is like, I don't know, 110 pounds, maybe in Mexico that'll be like 40 kilograms or something like that. Okay, um, because that's what they measure. So again, if you're 110 pounds here and you go to Mexico, you're about 50 kilograms. There you go. So, because in countries like Mexico and other areas of Europe, except for London or England, excuse me, use this kilograms to measure mass. I think England uses a different measurement. So the SI is used by the scientific community all over the world, although the other units are not necessarily. For example, again, going back, and I know I sound like I'm rambling. In scientific terms, the SI unit to measure mass is kilograms, but not necessarily that translate into other countries using the kilogram to determine mass. In fact, in other countries of the world, and almost all countries of the world, the weight of an object is measured in mass, except for the United States and England, which use different measurements. Okay, Um, and I'm going to give you an introduction to this real quick. We're going to talk about mass and weight. Okay. So we do know, one last thing. Another another unit used to measure the mass of small objects is the milligrams. So another unit used to measure mass of smaller objects is the milligram, right? And milligram is about 1/100,000th of a kilogram, or and 1/100 of a gram. Excuse me, 1/1000th of a gram and 1/100,000 of a kilogram. So the milligram is an extremely small unit to measure. Okay, so one 1,000, excuse me, of a gram and 1/100,000 of a kilogram. So again, we have, and it's actually smaller than, or yes, a milligram is actually smaller than a centigram, which I explained in the couple of minutes ago. Okay, so that was what we discussed today. The LMS, or your work for today, is on the LMS on page is on page 23. The chapter review on page 23. That's going to serve as a review for your test, which is on chapter 1. And hopefully this video will help you out. So I'll see you in your next class, guys. Bye-bye.